Okay, if you're given an equation that's in transformational form or vertex form, and you have to graph it, there's a couple of things that you can pick out of the equation right away that might be helpful. First of all, you may not necessarily use it all the time, but it's nice to know the a value just to know what it is and write it down just for future reference. And the other variables from our general equation are p and q. Some places we use h and k. Our work uses p and q, so let's do that. Now the vertex is given by the coordinates p and q. So right away from the equation, which is why we call this vertex form, is we can actually figure out what the vertex of this equation is right away. And it's 3, x is 3, y is 1, which is, let's say about there. And this is the coordinate 3, 1, and that's our vertex. Now, this parabola is opening down, and I know that because of the negative, so I know that my parabola should look something like this. Now, one way you can figure out some other points to plot are you could find your x-intercepts. Okay, now the questions vary. They might ask you to graph using the vertex and the x-intercepts only, or it might say graph using the vertex, the x-intercept, and another point, or 2 other points, or whatever. In this case, I'm going to find the x-intercepts. So I do that, as always, by setting y equal to 0. And I solve. Remember, solving means try and isolate x. So if I'm trying to get x all by itself, I'm going to try and get rid of these other things first. So I'll bring the negative 1 onto the other side of my equation, or subtract 1 from both sides. And then I'll divide both sides by negative 2. And so negative 1 divided by negative 2 leaves me with 1/2. And that is x minus 3 all squared. And then I have to square root that, so plus or minus the square root of 1/2 is x minus 3. And that leaves me with one of my x-intercepts being 3 plus root 1/2, or negative, 3 minus square root of 1/2. And if you were to do this in your calculator, then we would see that 3 minus the square root of 1/2 is about 2.3. And the other one, 3 plus the square root of 1/2, is 3.7. So 2.3 and 3.7. So about 3.7. And about 2.3. So 3.7 we'll say is about there. 2.3 we'll say is about there. And now if I wanted to, I could graph my parabola, or if I was asked to find another point, and it's always nice to do just to double check that you're sort of in the right space. So let's find the y-intercept, and I do that by setting x equal to 0, and I get y is equal to negative 2 times, now 0 minus 3 squared plus 1 is, 0 minus 3 is negative 3, negative 3 squared is 9, 9 times negative 2 is negative 18, negative 18 plus 1 is negative 17. And so my y-intercept would actually be, now if I'm following this parabola in this kind of a curvature, negative 17 might be somewhere way down here, which isn't necessarily an unreasonable graph that I have going. So that's a nice check for me. And there I have it. That's how I can graph using 1, 2, 3, and maybe a 4th point. And let's say I wanted to find the symmetrical y-intercept, or the buddy point to the y-intercept, then I would have a 5th point, and I've got a pretty good parabola. So if you're trying to graph from transformational form, find the vertex, that's the easiest part. Then find your x-intercepts, and that'll give you 2 more points. and maybe find the y-intercept, or if the question is only asking you to find certain things, you don't have to necessarily find the y-intercept. Maybe you do. That'll give you a nice check as to whether or not your graph looks reasonable. So there you go. The quick and easy way to graph a parabola if you're given the equation in vertex form.